These are your 4-1A notes, and we are going to learn how to graph quadratic functions in these notes. So again, just a little quick reminder that if you don't understand the concept fully after watching these notes, you need to re-watch the notes. Pay more attention to some details. So a quadratic function, we're going to now solve equations and graph equations where one of the variables is squared. And so they're no longer going to be of the form of a linear function, they're going to be of the form of quadratic. So that is the difference between a linear and a quadratic, is that squared term. The first term in a quadratic function, that ax squared, is called the quadratic term. That is the term that actually makes it a quadratic. The middle term, that bx term in this trinomial, is called the linear term. And then the number in the end is called the constant. So you can have any form of that function as long as the a value is not equal to 0. If the a value is 0, you won't have the quadratic term. Then you're not dealing with a quadratic function. The graph of any quadratic function is called a parabola. So to graph these things, we're going to go through all of the information about how to graph a quadratic function. And so there's some key elements and key points that we're going to label and use when we figure out our graph. So the parabola itself, that parabolic shape, it's like a U, but it comes down to a point, and that point is the vertex. So at the very bottom here, we have the vertex. And in the words above, the vertex, the x-coordinate of the vertex is equivalent to the opposite of b over 2a. Negative b over 2a. So I actually like the negative to be up top with the b value, the opposite of the b value over 2a. So when you find the vertex, you actually, that is your x-coordinate, and then to find your y-coordinate, you plug that in to the function to find your y-coordinate. Just like any other y-coordinate, you plug in the x and the function will give you the y. And the b and the a in that vertex is found within the equation. So using those numbers, a, b, and c in your quadratic function, you use those as a formula. The y-intercept is when c is equal to, or is when x is equal to 0. And so when you plug in 0 into a quadratic function, it ends up giving you just the c value. So if you plug in 0 and square it, you get 0 times a is 0. And then add b times 0, which is still 0. All you're going to end up with is the c value. So the constant is your y-intercept. And the y-intercept, again, is where the graph crosses the y-axis. So just by looking at the equation, you know the y-intercept. Just like in a line, you know where the y-intercept is. It's that number in the back. So we went over the y-intercept, we went over the vertex. This red dotted line going right down the middle of the parabola is called the axis of symmetry. It's a vertical line, so its name is x equals something. And the vertex is always on the axis of symmetry. So if you notice, the equation for the axis of symmetry is equivalent to the x-coordinate of the vertex. So in this particular example, if this was, let's say, 1, 2, 3 units over, the axis of symmetry, we would say, is the equation x equals 3. That tells me that it's a vertical line at 3. For the vertex, we would say that the vertex is over 3 units, but then we'd actually have to plug it in to find the y-coordinate. So the vertex is a point, the axis of symmetry is a line, but they share that negative b over 2a value. To graph these things, we're going to use a lot of the same concepts as we did with absolute value functions. We're going to find the vertex using negative b over 2a. We're going to look at it and find the y-intercept and the axis of symmetry. So we're going to find all of that information. We're going to make a table of at least 5 points, one of which is the vertex, 2 points to the left on the left branch, 2 points on the right branch. And then we're going to plot and label everything, and we'll sketch the parabola. So they won't be perfect because they're kind of making these rounded items, but I will be looking for 5 crucial points. So let's go ahead and get started with this. So we're going to find everything we can about this quadratic function. So this first quadratic function, f of x is equal to x squared plus 8x plus 9. If you look at it in terms of the a's, b's, and c's of that function, your a value is 1, because that's the number out in front of the x squared. Your b value is 8, because that's the number out in front of the x, or the linear term. And your constant value is 9. So now we have our a's, b's, and c's. A is equal to 1, b is equal to 8, and c is equal to 9. Sometimes it just helps to write those down. So my y-intercept is the easiest thing to find. My y-intercept is 9. It's equivalent to c. So you find c, and that's your y-intercept. Another way to write a y-intercept is the ordered pair 0, 9. So I know that this parabola hits the y-axis at 0, 9. So I'm just going to put a point at 0, 9. Now I can find the axis of symmetry and the vertex. So I'm going to use that formula, x equals negative b over 2a. So I write down the formula first. I'm going to require that today on your, or tomorrow on your homework. X equals the opposite of b, which is negative 8, all over 2 times a, which is 1. When I simplify that, x is equal to negative 8 over 2, which is equal to negative 4. So my axis of symmetry has an equation. It's a vertical line, and the vertical line is x equals negative 4. You got to put that x there. If you just say negative 4, I have no idea what you're talking about. When you say x equals negative 4, that's the equation of the axis of symmetry. So I'm going to go ahead and at negative 4 make a vertical line, and it's dotted. So 1, 2, 3, 4, I'm going to make a dotted vertical line. And this is going to help us graph because it shows symmetry. I'm actually going to make my y-intercept red so it matches my work. So my y-intercept work is in red. My axis of symmetry work is in green. Now we can do the vertex. So once I get that negative b over 2a value, I know my vertex is negative b over 2a and then something else. So my vertex is negative 4 something. And my vertex is always my middle point, just like in absolute value functions. So I'm going to put it in the middle of my table. To find out where it is, I know it's on the axis of symmetry. I just don't know how far up or how far down it goes. That's my y value. So I'm going to take this negative 4, and I'm going to plug it in for x squared, and I'm going to plug it in for x in my original function. And when I simplify that, it'll give me my value. So I'm going to do that down below. So f of x is equal to 1 times negative 4 squared plus 8 times negative 4 plus 9. Now you can use a calculator for this. F of x is the same thing as y, so I'm finding the y value when x is negative 4. Order of operation says I have to square this before I can multiply by 1. Now in this case, the 1 is just 1, so it's not going to change anything, but any other number, you want to square it first. So negative 4 squared is positive 16. Positive 16 times 1 is still positive 16. 8 times negative 4 is negative 32, and then we add 9. So when I simplify that, 16 take away 32 is negative 16, and negative 16 plus 9 is a negative 7. So my y-coordinate of my vertex is negative 7. So I'm going to go over 4 to the left and down 7, and label that with a V for vertex. So I know my parabola starts there. I know it's going to go through my y-intercept up here. We can either call that C or we can call that y-intercept. Okay, and so now I just need a couple more points. Well, actually, I'm going to use the ordered pair 0, 9 as one of my points to the right. So I can see that my y-intercept is to the right of my vertex. So I'm going to put that here. That 0, 9 is one of my points I'm going to use of my 5. And then using symmetry, I know that 0 is 4 units to the right of the vertex. So 4 units to the left of the vertex would be negative 8. So there's a matching point, negative 8, 9, on the left part of that branch that matches. So if I go over to negative 8, and up to 9, there's my other point. We can use symmetry just like we did with the absolute value functions. Now I just need to find one more point. So I don't care what one you use. I probably wouldn't go much further out than 0 and -8 because now you're going to get into really big numbers. But I wouldn't get too close to -4 either because now then you get really close to the vertex. So you just want enough points to give you some shape. So I'm actually going to stick with -2. I'm going to go 2 units right in the middle of 0 and -4. And so that's 2 units to the right of the vertex, and that would match up with 2 units to the left as -6. So I can either plug in -2 or I can plug in -6 to find this value. And you just simply plug it into the equation again. So just like we found the vertex, if I want to find y equals 1 times -2 squared plus 8 times -2 plus 9. I'm plugging in the x value, but I got to plug it in twice. I'm going to square the -2 first, multiply it by 1. I get 4. 8 times -2 is -16, and then plus 9. 4 minus 16 is -12, and -12 plus 9 is -3. So for my 2 new points, y is equal to -3 here, and y is equal to -3 here. So -2 gives me -3, and -6 gives me -3. And now you can kind of see your parabola taking shape. So we're going to connect, kind of curve, and point the bottom. There's your parabola. So there's the graph of the quadratic function.
Please excuse interruption. Can I have...
Okay. So next problem, we're going to do the same thing with this one. So we're going to first identify A, B, and C. My A value is the number out in front of the square term, 1. My B value is 3, and my C value is equal to -1. My y-intercept is the easiest point. You're looking at it, it's -1, or we can write that as 0, -1. So when I graph that, 0, -1 is right here. The next thing I'm going to do is do my x equals -b over 2a. When I use this formula, I get the axis of symmetry, and I also get the vertex. So x equals -b over 2a becomes x equals opposite of 3, which is -3, all over 2 times 1, which is -3 halves, which when we graph is -1.5. So my vertex is -1.5 something. My axis of symmetry has an equation. It's a vertical line at x equals -1.5. And so when I graph that, -1.5, I can see that my y-intercept is to the right. It's one of the points to the right, and I just got to figure out my vertex. So to figure out my vertex, I plug in -1.5 into the function. So y equals -1.5 squared plus 3 times -1.5 minus 1. When you square this, you could do it as a fraction or a decimal. When you square -1.5 times -1.5, you end up with 2.25. And 3 times -1.5 is equal to -4.5 minus 1. This is one of the most important calculations that you make. So now we're going to add 2.25, take away 4, and subtract 1, and you get -2.75. I feel like I did something wrong, so give me 1 second. There we go. So I ended up with -3.25 as my solution. So that is the y-coordinate of my vertex. So I'm going to come up here and put -3.25 in for my vertex, and I can put my vertex on my axis of symmetry. So I'm going to go down 3 in just a little bit. It's just a sketch. So that's my vertex. I'm going to use 0, -1 as the point right next to that. And so if 0, -1 is to the right of 1.5, it's 1.5 units to the right. 1.5 units to the left would match at -3, -1. So I can put that point on the graph. And I just need 2 more points. So I'm not going to go in between those. I'm actually going to go to +1 and -4. So there's symmetry there. They're both the same distance away from the vertex. So I can plug in 1 and I'll get the same answer as if I plugged in -4. So y equals 1 squared plus 3 times 1 minus 1. Y equals 1 plus 3 minus 1. Y is going to equal 3. So -4 gives me 3, and 1 gives me 3. And I have my 5 points for my parabola. And there you have it. It's really important that you get the axis of symmetry correct and your vertex correct. Otherwise, everything else will be off and it will not look like a parabola. So you got to really slow down. Not difficult math, but a lot of math. So the lesson summary, what is the graph of a quadratic equation called? And the practice problem, I want you to find the equation of the axis of symmetry. I want you to actually find the vertex, find the y-intercept. You do not have to graph that graph, but find those 3 elements of that quadratic function. Good luck.